Hi everybody, hope everybody's doing well. This is Joe with Scalar Labs. In today's session, we're going to give you a brief overview of ScalarDB. ScalarDB helps our customers simplify their data architecture, bringing them data consistency while decreasing the time and cost of developing and maintaining applications. In this session, we will discuss the characteristics, features, and advantages of ScalarDB. This session's primarily aimed at application developers, however, we'll also go over the business benefits of ScalarDB. We will discuss the challenges faced by siloed databases and managing data integrity across microservices architectures, and finally go over how ScalarDB can help overcome those challenges. So before we begin, what is ScalarDB? ScalarDB is not a database. The DB actually stands for data binder. It is a hybrid transactional analytical processing engine, or what we call an HTAP engine, for diverse databases that runs as middleware on top of databases. ScalarDB consolidates databases with ACID transactions and enables real-time analysis of your data, and we simplify the complexities of managing multiple databases. It enables ACID transactions and real-time analysis across multiple databases, including NoSQL, and even supports both NoSQL and relational databases working together. So what are some of our supported databases? Some of our relational databases we support include MariaDB, Microsoft SQL Server, MySQL, Oracle Database, PostgreSQL, SQLite, and compatible databases like Amazon Aurora, Google AlloyDB, TiDB, as well as Yugabyte. We also support multiple NoSQL databases like Amazon DynamoDB, Apache Cassandra, and Azure Cosmos DB. So what is database siloing? Database siloing refers to a state in which a database is used only within each system or business unit, and it lacks integration with other systems, and that results in becoming isolated. Database silos occur when data is fragmented across departments or when different types of databases are used. In a siloed environment, each system is optimized for the business process of each department. Now this has its advantages and makes it easier to focus on actions to achieve specific goals. As a result of each software being individually optimized, it becomes difficult to share data, resulting in data silos. The trouble with siloed databases is that even if a system is easy to use within a specific task or department, if the database isn't linked together with other siloed databases, it can reduce the business efficiency of the entire organization. So, what are other major challenges with siloed databases? The first challenge is how to access these fragmented databases effectively. For example, if the data is not collected in one place, it's difficult to perform highly accurate data analytics using AI. So what happens? Well, companies are forced to conduct data analytics manually or run their businesses on rules of thumb. Also, data analysis done manually can easily be mixed with subjective elements, and the accuracy is likely to be lower than objective analysis. How does this affect the control of different interfaces and access methods for each database, especially in a distributed system? Well, systems are optimized for the business process of each department, as illustrated here by Division A and Division B. They are often not designed to link with other systems and types of databases, and the access methods often differ. Siloed databases can make it difficult to utilize data collected by other departments. So for example, think about your sales department, manufacturing department, and the legal department. Each side obviously will have databases optimized for their particular business unit, but not for the others. But what happens when you have a recall issue or an IP infringement issue where the business needs access to critical information across multiple databases? This is not only a costly process, but is a tremendous burden to the database architects, engineers, and application developers, who have to manually create these new connections. And for the business side, it becomes extremely difficult trying to hunt down this information, and frequently, a lot of manual labor needs to take place. Managing different types of databases and distributed systems also means that each database has a different access point or UI interface, and each system would require additional development to access other databases, not to mention that the database vendor itself could be different. This can make it difficult to reconcile different databases and hinder collaboration between systems and departments. And when considering using databases that are managed individually by each department, maintaining data consistency can be a challenge and can cost the business. So here's a simple example. If a company happens to have multiple businesses or brands, like online retail for electronics, games, multimedia, and a fashion retail site, and their customer on the electronics retail site logs into their membership portal and updates their last name may be updated on the retail site, but there's no guarantee that the name would be updated across all databases. Now that's just the last name. What if we're dealing with money transfers across multiple siloed databases? or contract information, or mission-critical data. You would want to have the data seamlessly made consistent across all datasets. The other challenge is managing duplicate data in different departments, which means duplicated effort and ever-increasing costs because data will only grow with time. So how can ScalarDB help? With ScalarDB, you can achieve the following for siloed databases. Consolidate different interfaces for each database, unify access methods to siloed databases, and ensure guaranteed strong data consistency across multiple different databases. What we provide is a unified interface for different databases, allowing multiple types of databases to be treated as if they were a single database. From a workload and financial standpoint, being able to use the same interface and the same access methods helps to reduce headaches for the application developers and decreases development costs for the business, providing stable applications to the end users or customers, and for the business to be able to focus on the business. ScalarDB also provides ACID functionality for non-ACID compliant databases such as NoSQL. As a result, it makes it possible to perform transactions between multiple types of databases, including NoSQL, and makes it easy to manage data consistency. In a microservice-based architecture, each database is accessed by a corresponding service, and it's a challenge to ensure data consistency across microservices. The application needs to implement compensating transactions using Saga pattern or TCC, and this needs complicated logic to be implemented in the application. Also, some NoSQL databases are ACID compliant to some extent, but still have restrictions. Consider a case where there are three microservices, A, B, and C. Microservice A manages a relational database. Microservice B manages a limited ACID compliant NoSQL database, and Microservice C manages a NoSQL database that is not ACID compliant. In this case, it may be possible to achieve transactions between microservices A and B by making use of the Saga pattern. However, you're not able to include microservices C, and data inconsistencies arise. ScalarDB makes it easier to implement ACID transactions across multiple types of databases. ScalarDB also provides ACID transaction functionality for non-ACID compliant databases, so you can use ScalarDB to run ACID transactions across multiple services, even if the underlying databases are different types of ACID compliant or non-ACID compliant databases. It also reduces development effort by eliminating the need to implement complex compensating transactions. While it's true that transactional systems that span multiple services can be developed using Saga patterns, without ScalarDB, microservices require compensating transactions. What that means is that developers need to spend time and money to write different code for each type of database. As you can imagine, as your business grows and your application incorporates additional innovations, this becomes increasingly complex, affecting business focus and growth. And on the development side, you end up losing the flexibility to continuously innovate. So without ScalarDB, not only do you have the compensating transaction problem and having to write different code for each database and having less flexibility, you also have the complex logic that you need to write for each failure case. ScalarDB supports transactions across multiple microservices. So what this means is it simplifies development of microservices that require transactions. And you can access each database using a unified interface, so there's no need to write different code for each database, and no compensating transactions are required. And the transaction execution code itself is simplified. There's no need to consider failure scenarios across multiple services and write test cases for each of them. So this makes application development across your business efficient. Now let's have a look at ScalarDB the product. ScalarDB is available in open source and commercial licenses. The Commercial Enterprise Edition comes in two versions. One is the standard version and the other is the premium. In the Enterprise Edition, ScalarDB offers a clustering solution. In the clustering solution, each node provides ScalarDB functionality. The ScalarDB cluster offers multiple interfaces such as gRPC, Java API, SQL, Spring Data, GraphQL, and .NET SDK. The standard version offers only gRPC and Java API interfaces. In this training program, we'll discuss more details about the ScalarDB architecture, the ScalarDB data model, prerequisites for implementing ScalarDB, and then we'll focus more on a practical approach by creating a sample application and building a simple console application. Then we'll study an application using microservices architecture. We're looking forward to providing you with informative content and look forward to seeing you in the next session. Hit subscribe and stay updated on everything Scalar.